All right, here we are again. Um, Tonight you guys are going to be taking a look at section P4, which is factoring polynomials. Again, you have done this kind of factoring throughout your Algebra 2, so it's just a lot of review. Still not as bad as that section 2 was as far as information in it, but there's going to be quite a bit. So if you would open up your textbooks, you all need to be on page 34. Get your notebooks out. Again, the expectation is that you guys are taking down the notes that are in these sections that I'm posting online. All right, so a factor is a number or variable that can be removed from two or more algebraic terms. So when you're looking at this problem up on the board, has two terms in it. So it's a polynomial or a binomial. What can you take out of the first term and what can you take out of the second term that match? So look at your regular number parts first. Notice that you can get a 5 out of the first one and the second one, and they both have x's in them. How many x's can you get out of both? Well, each one has at least an x squared in it. So write down 5x squared, that's your common factor, and then in a parenthesis next to it goes what you are left with. So if I divide a 5x squared out of the first term, I'm left with x. If I divide it out of the second term, I'm left with negative 3. Okay. Now turn to page 35. You're going to see a box at the top of the page that lists how to factor some special polynomials. Please write these in your notes. So why don't you go ahead and hit pause for a little while so that you have time to write those factoring patterns into your notebook. You have difference of two squares, perfect square trinomials, sums or differences of two cubes. Now let's try practicing with a few of these things. Now take a look at example number A that I have on your slide for you first. Which one of these special deals is this one? Well, you can see that it is a subtraction, so we've got a difference of something. The first term is a squared term, and the second term is a squared one, so this is a difference of squares. Now, if you remember from the past, or you remember from the box that you just copied down, the factors are going to be the square root of the first term and the square root of the second term. One of the factor parentheses will have a plus sign in it. The other one will have a minus sign in it. If you were to FOIL together those products again, you would notice that your inside and outside terms, the O and the I part of FOIL, one's going to give you a positive 7x and one's going to give you a negative 7x. And they would cancel each other out, which makes perfect sense then why that original problem started with just two terms in it. Okay, so you can feel pretty good that you probably did that one right. Get that back out of there. Moving on to the second one, see x cubed plus 27.
Will you please come to the office? Summer Larson to the office.
Sorry about that. The first one, x cubed, is obviously a cube term. There's a plus sign in it, so that's a sum. And then the 27, it is 3 times 3 times 3. So that's another cube number. So if you remember from the pattern, our pattern said that the first factor would be the cubed root of both pieces. And the sign between them is going to match the sign that was in the problem. Now the second parenthesis is going to have a trinomial in it. The first is going to be the square root of the first item. Okay, so our first cube was x, so x squared. Now is going to come a minus sign in the pattern, and you're going to subtract the cubed root of both of them together. So the cubed root of the x cubed was an x, the cubed root of the 27 was a 3. So that middle part of this factor is going to be a 3 times x. The final term in there is going to be the square of the cubed root of 27 which is 9. Okay. If you were to multiply those two things together, you should find that everything cancels out other than the x cubed and the positive 27. All right, you could go ahead and try multiplying that back up if you want to check yourself. And when it comes to a quiz or a test, I would suggest you do that just so that you remember where the negative sign is supposed to be, where the positive signs are supposed to be, and all that, because usually that's the only thing that gets messed up too much. All right, so C, we have a cubed term minus 64. So again, it's up to you to figure out that 64 is another cubed number. 64 is 4 cubed. So if we begin factoring this one, again, using a pattern, the difference of perfect cubes, the first factor is going to be the cubed root of both in the parenthesis. And the sign in between them will match. So x minus 4 starts us off. The second one is going to be the square of x. The next sign is going to be a plus sign. The next term in that factor will be an x times a 4. And then the last term is to add 4 squared, or 16. Okay, so those are pretty basic ones, but that truly is the principle behind the whole thing. All right, it isn't any harder than what you see. Now, looking at the bottom of page 35, this is a little bit more complex, but take a close look at it. The first chunk of it, x minus 1 to the second power, that's a squared term. An x minus 1 and another x minus 1. The second chunk of it, 9y to the fourth, that's another squared term. 3y squared and another 3y squared. So let's factor this with our difference of squared patterns. So your first factor will have one of the x minus 1's plus 3y squared. And the next one will have another x minus 1 minus 3y squared. So maybe it looks a little funny, but it's the same exact property use as on that easier one on the page before. Another kind of polynomial that has a pattern factorization is the perfect square trinomial. All right, we're now looking at the top of page 36. If when you're doing a factoring exercise, you notice that the first term is a perfect square and the third term is a perfect square, it's very likely that it's going to be one of these perfect square trinomials. Okay, so take a look at the example that I put in this slide. The first term is 16x squared. Well, that's 4x times 4x, so that's a perfect square number. And then the last number is a 9, so that one again is a perfect square, 3 times 3. So if we were going to factor this thing, try putting a 4x plus 3 and a 4x plus 3 into the parentheses. Okay, of course you have to check it through your FOIL. We know that the 4x and the 4x give us the 16x, and the 3 and the 3 give us the 9. Do your inside and outside parts of FOIL. 12x and 12x give you the 24x in the problem? Yeah, they do. So this one's going to work. Now another way that this answer might ultimately be written is like this. So you can show that there are two exact factors by using that power of 2 as well. I really don't care how you leave your answer. Two more factoring patterns that you need to know are sums of cubes and differences of cubes. We talked about them just a tad bit a little earlier. So you may very well have copied them down out of the table from page 35 already. I hope so. So let's just do a little bit more practice with those sums of cubes and difference of cubes. So these aren't a whole lot harder than those other couple that we went through previously. But take a look at letter A. 64x cubed would be 4x times 4x times 4x. I'm going to write that off to the side so that we remember what our cubed roots of those pieces are. And then, of course, the cubed root of 1 is 1. So using your pattern, this one is a difference of cubes. So your first term is going to be 4x minus 1. Now the second parenthesis, you square the first piece, you change the sign and multiply, you multiply your two cubed roots together, so we would have 4x. And then the last one is the square of the second cube, which would still be 1. Okay, again, if you were to multiply this thing back together, it should bring you back to 64x cubed minus 1. All right, so everything but those two things should end up canceling away. All right, so B, our cubed root of our first term is x, and the cubed root of your second term is 6. So let's apply that pattern. What's your first factor going to be? It's a sum of these cubes. So the sign matches in the first parenthesis. Now, square of the first cube minus the multiplication of the two cubes plus the square of the second cube. Now look at C. All right, C doesn't start out real pretty because 5y cubed isn't a perfect cube and 135 isn't a perfect cube. But if you were to begin factoring something that looked like this, you should notice that you can pull a 5 out of both those numbers. So let's start there. So we've got a 5 and then in parentheses y cubed plus 27 would be left. Now take a look at your inside parenthesis. Now y cubed is a perfect cube. 27 is a perfect cube. So we move on. So leave your 5 where it's at. That's already a factor that's been pulled out. Y plus 3 would be our first chunk. Y squared plus 3y. Oh, take that back. Y squared minus 3y. Should be a negative in there since it was a sum. Plus 9. And then that one's done. Now the next trinomials, you're going to have to factor these out, but they're not patterned ones. So now you have to remember that whole concept of how to factor a trinomial. If the coefficient is 1 on your lead term, all right, so do you see how the coefficient of x squared is a 1? All you need to do are find factors of 20 that are going to add up to make 9. So start thinking about factors of 20. We've got 1 and 20, 2 and 10, 4 and 5. So when you look at those pairs that would give us the 20 that we need, which one would give us the 9 that we need? That one, right? So there's your factors, x plus 4 and an x plus 5. You guys remember doing that? Let's go to another one. Now when the lead coefficient isn't 1, the factors of the first term have to FOIL with the factors of the last term to make the coefficient of the middle term still. Okay, now this one that I gave you isn't bad, but you do have that 2 out front to consider. So this is what I do. I know that the first terms have to be 2x and x, so I put them in. Now, I need to come up with a negative 5, so I'm breaking my 3 into possibilities. Okay, well, I'm going to need to get a negative 5, when I add, which means both of my signs are going to have to be negative inside so that they still multiply to make a positive, but combine to make the negative 5. All right, so you might have to play around with this. Your only options, nicely enough, are a 1 and a 3 to put in those other two spots. So let's say that you decide to go like this. Okay, so the positive 3 is there, the 2x squared is there, but what does your in and out make? We get negative x inside, negative 6x outside. Those two are going to combine together to make negative 7. That is not what we're looking for. So they're in the wrong spot. So, if that's the case, take them back out and switch them. How about if we put the negative 3 here and the negative 1 here? Now inside, we have negative 3x. Outside, we have negative 2x. Those two do give us the negative 5x. So then, here's your set of factors. Here's your answer. The very last factoring that we're going to take a look at is when you have 4 terms in your polynomial. If you think back, you did this factoring by grouping back in Algebra 2 as well. The dead giveaway when you need to use this method of factoring is when you've got 4 pieces. So write this example down. X cubed plus x squared minus 5x minus 5. I even physically draw the line down the center. Take a look at your front half. What can you pull out of both pieces of your front half? X squared. And when you pull it out, it leaves you with an x plus 1, right? Okay, now we're hoping for maybe finding another x plus 1 in the back chunk. So take a look back there. What can you take out of both terms? Hopefully you see that you can get a negative 5 out of there. And then that would leave you with another x plus 1. So looking at the chunks, do you notice that the x plus 1 and the x plus 1 match? So pull it out. And then the leftovers of both chunks go in a second parenthesis to finish. And there's your factored form. Okay, hopefully everybody kind of recalls seeing that in the past. I always liked that one, just because when I saw the 4 pieces, I knew I was going to use it. All right, folks, I'm going to cut you loose on your homework then. Turn to pages 39 and 40. We're going to start with number 6, and we're going to do that every third one again like we've been doing. Okay, if you have questions on any, if you get started on tonight, make sure you pop in on me. And if you got your notes and stuff all taken care of and out of the way, you'll have the entire class period to work. See you tomorrow.